Hey guys, so today's lesson is going to be about looking at powers of 10 and writing powers of 10 and kind of the patterns behind that, as well as learning about what scientific notation is and how to write numbers in scientific notation. So it's kind of an introductory lesson. It's probably one of the easier lessons that you're going to have. And a lot of you are probably thinking, oh, this is easy, like I can do all this. But what we're trying to do here is to understand the patterns of these numbers and how we can use those in writing things in scientific notation and how we can write things as powers of 10 and evaluate them. Now, typically when I do this lesson in class, I have kids get out a calculator and I have them evaluate each of these exponents here. So if you were going to evaluate 10 to the 5th, and a lot of kids associate this with they're like, oh, that means 5 zeros. And, while that's a really great first thought, that's actually not really what's happening here. It's one of the easiest ways to kind of explain what you see visually, but it's really not the rule behind a power of 10. So then if I did this, the commas can be really important here. Helps us know like how big the number is and make sure I've written all the correct pieces. And then 10 to the negative third, I typically don't have kids do this right away in the calculator. I ask, okay, what do you do with the negative exponent? Well, I put it in its reciprocal home, which would mean this would be 1 over 10 to the third, and this would be 1 over 10 to the fourth. And then I have them divide it, which you can do it either way, but that way they understand that, or try to remember that this isn't going to make the number negative. That's definitely not what it's going to do. So when I evaluate these, this is what I get. Now, the rule is, it actually has nothing to do with zeros here. And that's one of the common misconceptions kids have. And I'm gonna try to move things down a little bit because I really want to be able to write some stuff. And you have to bear with me, like doing these videos, I don't like write myself a script, so I'm kind of just winging it half the time. But anyways, so the rule is it has nothing to do with zeros. Nothing to do with the number of zeros. But the exponent on a power of 10 tells you how many times to move the decimal on the number 1 left or right. And I apologize, my handwriting's really messy. So it's all about place value. And to be honest, I hated place value when I was in school. I just I don't know, I just didn't enjoy learning about it, to be honest. But so the rule for finding powers of 10 has nothing to do with the zeros. Okay? The exponent on a power of 10 tells you how many times to move the decimal on the number 1 left or right. So for example, if I go back to this first problem, if I were to start with the number 1, hopefully all of you know that the decimal is right to the right of that number, right? So if I were to start with the number 1, which is the starting number for most things in mathematics, some would argue that it's 0, but if I start with the number 1, that's saying, okay, the exponent is 5. I'm going to move that decimal 1, 2, 3, 4, 5 times to the right. Now, some kids are wondering why would I move to the right? Well, it's a positive exponent. So logically, positive numbers go to the right on a number line. It's the same thing with the decimal. So now all these empty spots here could be filled with zeros. 2, 3, 4, 5. And I end up with the same number that I had below. So if I look at this next example, starting with the number 1, that is telling me to move the decimal 8 times to the right. If I took this, I go 1, 2, 3, 4, 5, 6, 7, 8, which means I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 zeros. Same number that we had down below. It's really hard to write on here. Now, this rule is especially important because a lot of kids will say, well, Miss Maya, I could have just added 8 zeros. I could have just added 5 zeros. Nah. What about when you start with the number 1 here on this next example? And that does not look like a 1. It looks like a, I don't even know. This is going to be a longer video. I apologize. Okay, so this is my 1. Remembering that the decimal's here, right? So what that's saying is, all right, I'm going to move the decimal 3 times. Well, it's a negative decimal. It's a negative exponent. So I'm going to go to the left because negative numbers logically go to the left on a number line. So if I move that 3 times, I have to actually pass the 1. 1, 2, 3. So now you can understand it's not about the zeros, it's about the number of times you move the decimal, the number of place values before or after the number 1. So if I looked at this example, this last example here, that's saying move the decimal. I gotta move this over. 4 times to the left. 1, I have to pass the number 1. 2, 3, 4. So I'm actually only adding 3 zeros here. So remember, it's not about the zeros. And a lot of kids eventually understand that if it's a negative exponent, it's going to be 1 less 0. If it's a positive exponent, it's going to be the same number of zeros. So that's kind of an example of how I would write powers of 10. Now, if I kind of go in the reverse, how do I actually write these as powers of 10? So remember, we're always thinking about the number 1. So I need to think about where's the decimal in each of these problems. And I kind of highlighted it on each of these. And how many times do I have to move this to get back to the number 1? 1, 2. So this would be 10 squared. I'd have to move this 1, 2, 3, 4, 5, 6. So that would be 10 to the 6. I'd have to move this. How many times do I have to move this to get to the number 1? Well, a lot of kids are like, well, 1, 2, 3, 4. Yeah, I'm not at the number 1 yet. I'm at 0.1. So I need to move it 1 more time, which means I actually moved this 5 times. And remember, because it's a decimal, you kind of have to remember the rule that that's going to be a negative exponent. 1, 2. Hopefully you were able to kind of write this in your notes. I know I'm talking a lot. Sometimes it helps to go back and rewind the lesson or pause when you need to. That's the beauty of this. You can pause it. It's actually kind of better than me teaching you in class because you can look at it as many times as you need. Okay. So now we're going to talk about multiplying by powers of 10. So for example, I have a couple examples there. This is what we call standard form. So in your note sheet that I'm asking you to fill out, that was part of the lessons on the website. This is what's called standard form because it shows the actual value of the number. So in order to write something in standard form, I actually have to find the answer. So the beauty of a power of 10 is hopefully you understood from the previous slide that it's all about how many times you move your decimal. It doesn't really matter what this number is. All that matters is this is telling you right here tells you how many times to move your decimal. So what that is telling me is I need to move my decimal 3 times, and because it's negative, I'm going to go 3 times to the left. So if I actually were to do that and write this in standard form, which means find the actual answer, what is the value of this? I move it 1, 2, 3 times. And I don't think, and I apologize on the previous slides, I didn't really explain why we add zeros in there. Well, if I'm moving the decimal, I have to put something in place of those spaces I've created. So those spaces we fill with zeros. So if I moved this 3 times, like I said, this would become 0.0032. That would be my answer in standard form. Now, if I look at this next example, what that's saying is move my decimal 4 times, and I'm going to go to the right because it's a positive number. So if I move this 4 times, I'm going to move this number down here so that we can see it. I'm going to go 1, 2, 3, 4. Filling in the empty spaces with zeros. So that in standard form would be 438,000. So making sure you kind of put some examples for yourself. Remember, this is all about moving decimals, left and right. That's all we're looking at here. How many times we're moving the decimal left and right? And what number are you starting with? Now, the reason we went over these couple slides is because of what we're going to talk about here. This is really where we're headed for this lesson and the next few lessons that we talk about coming up. Scientific notation, and I would write this definition down. I left you some space on that graphic organizer. So scientific notation is a method of writing numbers that are really large I wish it would let me double highlight, but it won't. Really large or small in a more condensed form. And the form is written as a product. I'm going to obviously go into more detail here, but in math, in science, this is really useful in science. Remember, science and math are very connected. You often deal with very small numbers or very large numbers if we're talking population or if we're talking, I don't know, percentage of humans that have 25 toes. Like talking about things that could have really large numbers or really small numbers. So for example, that's a really big number. Not many of you could actually verbalize that number to me. You might not even know what that number is in words. Or a number like this. I personally don't want to have to read all those zeros, and I think my eyes would get kind of confused trying to like figure out, did I say the right amount of zeros or not? So what scientific notation is, it's a way of writing these numbers in a more condensed way so scientists or mathematicians can look at them and they're easier to verbalize. You can see how big they are by the way that you write them or how small they are. So there's a couple rules for scientific notation. I'm going to put these numbers aside. So rules. Written as a product. Remember, product is an answer to a multiplication problem. So it's written as a product with a power of 10. So I'm going to put an example of something written in scientific notation. It's kind of the opposite of standard form. So this is something in scientific notation. Now there are a couple rules about how to write things in scientific notation. This number has to be between 1 and 10. The reason being, the whole point of scientific notation is to make numbers more condensed and to write them in a smaller way. Well, what are the smallest numbers that we have on the planet? And what I mean, what are the most easily written numbers that we have? And those would be the numbers between 1 and 10. And there's another rule. And not everyone follows this rule, but I follow this rule just because I think it's a little bit easier to write things. You always, for me, want to round to 1 decimal. And actually, I think I'm going to change this for you guys. I apologize. I'm going to change this to 2 decimal places because of the numbers that we look at here. They're going to be easier when we do 2 decimal places. So something in scientific notation is written as a product with the power of 10. The first number has to be between 1 and 10, and it has to be rounded to 2 decimal places. And hopefully you guys understand that this tells you number of place values or times you moved your decimal. Okay, so I know it's a long video. I'm really sorry. It's okay. Actually, it's really not that long compared to how it would be in real life because I talk a lot. And Corey distracts me, right, Corey? Same with you, Drew. All right. So hopefully you got that written down. We're going to actually go over a couple examples. I'm going to use those couple numbers that I had written up here. So this would be a really good example to write down for yourself on that graphic organizer. So if I were going to write this in scientific notation, currently this is standard form. And we're going to write this in scientific. So the first rule was, we're trying to make this more condensed. And in order to make it more condensed, I need to get rid of a lot of those place values. I don't want to change the number. That's not what we're doing. But anyways, I am trying to figure out where could I put the decimal in this number so I have a number between 1 and 10. Well, if I put the decimal here, that's definitely not between 1 and 10, right? So hopefully sitting there, you're like, wow, Miss Mari, the only place I can put the decimal would be right here. If I put the decimal right there, that would give me a number between 1 and 10. That's the first rule. You need a number between 1 and 10. So the decimal was originally here. How many times did I have to move that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I moved that 12 times. So now what I'm going to do, I'm going to write this number down, and I know some of you are like, you can't write that number, that's not right. Well, we're going to get there in a second. And I moved that 12 times. Now, some kids get confused here. They're like, well, wouldn't it be a negative 12, Miss Mari? You moved it to the left. I know I moved it to the left, but the number is not a decimal. The number was this big whole number. So if I wanted to take this and go back to here, I would really want this to be a positive, not a negative. So it's backwards thinking. Now the other thing is this needs to be rounded to 2 decimal places. So if I were to do that, this would be improper scientific notation. Now, as a math teacher who's worked with scientific notation many times, when I look at that number, I'm like, dang, that's a big number. Holy crap, that's got a lot of place values. 12? Oh my gosh. So that tells me it's a really large number, but I didn't have to write it in such a large way. So it's kind of more useful. Now I realize if I were to re-expand this, I'm not going to get the exact same number I got before. And I just realized that's originally how it was written. Oops, no it wasn't. Sorry guys. I forgot that 2 there. Some of you are like, where'd the 2 go? But anyways, scientific notation is kind of like a rounded version of the number, is another way of thinking about it. I mean, all those extra numbers, the 3, the 0, the 4, the 2, really aren't going to change the fact that that's a really large number. So now let's do another example. Yeah, I'm going to just move this down here. So this is written in standard form. And I want to write this in scientific notation. So if I were going to write this in scientific notation, the first thing is we need to move the decimal so that we end up with a number between 1 and 10. So if I were going to move this decimal 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if I moved it here, I would have the number 3.64. That is between 1 and 10. If I moved it again, I would have 36.4. That is not between 1 and 10. So this would be the proper place. So I have the number 3.64. I moved it 11 times. Now, because this is a decimal, this would need to be a negative exponent. So if I were going to go back to here, I would want that to be a negative exponent, so I know it needs to move to the left. So remember, it's backwards thinking. This is rounded, so it's good. I have 2 decimal places, so I don't have to do any crazy rounding or thinking. So this is in proper scientific notation. So what I would do, and I know it's a long video, but that's okay. You're fine. You're going into honors math next year. I would pause this video, go through these few problems real quick, and then check your answers, because I'm gonna write the answers down. And so take a minute to pause this, try these few problems out, check your answers, and then you'll be ready for your next lesson. Okay, so here are the answers. Really good way to check your answers, kind of look at, obviously I don't want you to think about the zeros, but just look at the zeros. It's a good way of making sure that you have the right amount of spots or commas. That's helpful. So I think the most common mistakes I would see would be maybe in this, oh, not what I wanted, would be in this problem and this problem here. So remember, this exponent is telling you how many times to move the decimal. So it's saying move it 1, 2, 3 times. And if I move that 3 times, I end up with the number 50. Okay? And then if I'm looking here, in order to start with that number, I need to move it to a place where I have a number between 1 and 10. That would be right here. So I'd end up with 4.008 times 10 to the, how many times I move that? 3, 4, 5, 6, 7. 7 times. But remember, you want to round to 2 decimal places. So if I do that, you have to pay attention to this number, because if it's 5 or above, you give that a shove. So that's where I got that 4.01 from. So hopefully that gave you some help. Definitely let me know if you have any questions, and yeah, alrighty, bye guys.